fuel is pretty disgusting stuff, but we're pouring 20 gallons or 80 litres of it into this tank of water to create our very own oil slick. And what we end up with is a layer of oil a few millimetres thick, like this. We've actually put red dye in it to make it easier to see. Now, if this was the ocean, wave action would combine the oil and water into an emulsion, making it almost impossible to separate the two. In fact, if you pumped the oil out, you'd be lucky to recover, say, 50%. Hundreds of thousands of litres of oil are spilled or seep into the world's oceans and waterways each year. Often the oil is left to disperse by wind and wave action. Clean-up operations, when they are carried out, are time-consuming, expensive, and frequently ineffective. A popular method is to spray dispersants on the oil to make it blend more readily with water. Some of the oil will evaporate, but the rest will eventually sink to the bottom. But this is a less acceptable alternative to removing the oil completely. The secret is to find something to separate the oil from the water, and the answer is chewing gum. ELASTOL is 80% polyisobutylene, which is the substance which makes chewing gum chewy. Well, it's chewy, but it's not big on flavour. ELASTOL is made by freezing polyisobutylene in liquid nitrogen to minus 80 degrees Celsius, or minus 190 degrees Fahrenheit. At this temperature, it changes from rubber to a glassy substance, which can be ground into a powder. To prevent it from sticking together, the powder is coated with a food additive called calcium stearate. For easy application, ELASTOL powder is mixed with water to form a slurry and sprayed directly onto the oil spill. Its long, thin molecules dissolve and modify oil, turning it into an elastic substance which is much less likely to disperse. The astonishing thing is, for the 20 gallons of diesel we put in here, it only takes half a cup to effectively treat it. The manufacturers, General Technology Applications, say the amount of ELASTOL needed depends on the viscosity of the spilt oil and varies from 500 parts per million to 5,000 parts per million ELASTOL to oil. It's already become quite viscoelastic, but it will take another half an hour before it's ready to be cleaned up. Of course, in the ocean, the wave action mixes the ELASTOL and the oil much more quickly, so that you end up with a distinct layer of ELASTOL and oil floating on top of the water, and that can easily be removed. In the laboratory, you can see just how effective ELASTOL is. Untreated oil is very difficult to lift off the surface, whereas the ELASTOL oil mixture lifts in a continuous stream.
Cleaning up is a bit like doing the vacuuming. Better still though, GTA's engineers have developed the drum skimmer, which does the job in a quarter of the time.
The drum skimmer uses 3 Teflon-coated drums to pick up the ELASTOL oil mixture, which is skimmed off into trays and drained away. Using ELASTOL, 97% of the oil is quickly picked up, leaving the river or ocean remarkably clean. Without ELASTOL, at least half the liquid recovered would be water. ELASTOL can also be used for ground oil spills. If you've ever spilt oil in the garage, you'll know how difficult it can be to clean up. Putting sawdust on helps, but it doesn't really absorb the oil and you're left with a gungy mess. But when you combine ELASTOL with the sawdust, the ELASTOL coagulates the oil within seconds. Promising though ELASTOL may be, the manufacturers are finding market acceptance is slow. They say clean-up companies are paid by the hour, and ELASTOL does the job too quickly and too efficiently. Hopefully, for the sake of our environment, that attitude won't stick.